Hello YouTube, this is Jay Coder back with another video here, and so we're going to continue from where we left off yesterday. We were working with collections in Kotlin and going over lambdas, and so if you like to improve in Android and want to become an Android professional, this is the goal of the channel. Go ahead and subscribe and like this video and comment on this video. And without further ado, I'm gonna go ahead and continue with the lesson. And again, if you missed the first part, you can always check out part 1 of this streaming video and it should catch you up to speed. With this video, we're not working with Android Studio, so you don't need to open Android Studio right now. We're going to be working in the Kotlin Playground like we were yesterday. So I'm just going to go ahead and post this link to the Kotlin to the code lab that we were working on, collections in Kotlin, and also I can go ahead and post a link to the Kotlin Playground for anyone who is joining that wants to go ahead and catch up with us and begin where we're beginning. So, alright, I posted those links. I'm going to go ahead and mute the music and I'm going to go ahead and continue where we left off. So, basically we left off around this area where, we were having this code right here printed out, and we're using lambdas, and so basically we are going through the different types of collections in Kotlin. But anyway, I'm gonna go ahead and copy this code here, and so they wanted us to go ahead and put this in our playground, and then we were going to go ahead and play it. So what this does is it basically loops through and actually what it does is it takes whatever is passed in here and times it by this number, and so it's going to be 15. And so note, it's common to have a lambda that has a single parameter, so Kotlin offers a shorthand. Kotlin implicitly uses the special identifier it for the parameter of a lambda with a single parameter. Within the curly braces, you can omit explicitly declaring the parameter a :int, omit the function arrow, and just have the function body. Update the triple function declared in your main function and run the code. So instead of having that, we can also have this where we can go ahead and it shortens that same version, so you don't have to have this, and you don't have to have that, and you don't have to have that, and you don't have to have that, and essentially this does the same thing as this above line here. So which is good. There's a lot of opportunities in Kotlin to shorten the code, and that's what one of the goals is as a whole, is for Kotlin to be able to do powerful things in less lines of code. Higher order functions. Now that you are starting to see the flexibility of how you can manipulate functions in Kotlin, let's talk about another really powerful idea: a high order function. This just means passing a function, in this case a lambda, to another function, or returning a function from another function. It returns It turns out that map, filter, and for each functions are all examples of high order functions because they all took a function as a parameter. In the lambda passed to the filter high order function, it's okay to omit the single parameter and arrow symbol and also use the IT parameter. People's ages.filter, and then inside there is it.key.length is less than 4. And here's an example of a new high order function sorted with. If you want to sort a list of strings, you can use the built-in sorted method for collections. However, if you wanted to sort the list by the length of the strings, you need to write some code to get the length of two strings and compare them. Kotlin lets you do this by passing a lambda to the sorted with method. Note, to compare two objects for sorting, the convention is to return a value less than 0. If the first object is less than the second 0, if if they are equal and a value greater than 0 if the first object is greater than the second. In the playground, create a list of names and print it sorted by name with this code. So, alright, so they want us to go ahead and print this list sorted here. Let me see. Okay, so we're going to go ahead and put this in our Kotlin code, our Kotlin Playground. And so it's a list of people's names. And then it prints the people's.names.sorted there. And now print the list sorted by the length of the names by passing lambda to the sorted with function. The lambda should take in two parameters at the same time and return an int. Add this line of code after the print line statement in the main function. So we have this here. We're going to go ahead and copy that. And then we're going to print it like this. So people's names sorted with, then so it's sorted with, and then string 1, string 2, to string 1.length minus string 2.length. And so this is now print the list sorted by the length of names by passing a lambda. That's the length of names. By the length of names, it is sorted. The lambda should take in two parameters at the same time and return an int, and add this line of code after the print ln statement. So now it's sorted by length of the name. Okay, interesting. So interesting. Okay, so the lambda pass to sorted with has two parameters, string 1 and string 2, which is a string. Then you see the function arrow followed by the function body. Remember, so the function arrow followed by the function body. And then is string length 1 by string length 2. Remember, the last expression in the lambda is the return value. In this case, it returns the difference between the length of the first string and the length of the second string, which is an int. That matches what is needed for sorting. If string 1 is shorter than string 2, it will return a value less than 0. If string 1 and string 2 are the same length, it will return 0. If string 1 is longer than string 2, it will return a value greater than 0. By doing a series of comparisons between two strings at a time, the sorted with function outputs a list where the names will be in order of increasing length. On click listener and on key listener in Android. Try this back to what trying this back to what you have learned in Android so far. You have used lambdas in earlier collabs, such as when you set a click listener for the button in the tip calculator app. Using a lambda to set the click listener is convenient shorthand. The long form way of writing the above code is shown below and compared against the shortened version. You don't have to understand all the details of long form version, but notice some patterns between two versions. So calculate.button.set click listener. So set click listener. Let's see. Oh, okay. So, well, yeah, they're showing that as an example. Using a lambda to set the click listener is a convenient shorthand. The long form way of writing the above code is shown below and compared against the shortened version. You don't have to understand all the details of the long form version, but notice some patterns between the two versions. So long form is this, and then the short form is this. Okay. Observe how the lambda has the same function type as the onClick method in onClick listener. Takes in one view argument and returns unit, which means no return value. The shortened version of the code is possible because of something called SAM, Single Abstract Method conversion in Kotlin. Kotlin converts the lambda into an on-click listener object, which implements the single abstract method on click. You just need to make sure the lambda function type matches the function type of abstract function. Since the view parameter is never used in the lambda, the parameter can be omitted. Then we just have the function body and lambda. Calculate button dot set on click listener, calculate tip. These concepts are challenging, so be patient with yourself as it'll take time and experience for these concepts to sink in. Let's look for another example. Recall when you set a key listener on the cost of service text field in the tip calculator so the on-screen keyword could be hidden when the enter key is pressed. So they show this code example here with the set on key listener and basically setting up the something to do with the keyboard, dismissing the keyboard when button is pressed. When you look up on key listener, the abstract method has the following parameters. On key, they show this on key view v, int key code, key event, and returns a boolean because of SAM conversions in Kotlin. You can pass in a lambda to set on key listener. Just be sure the lambda has the function type view it key event and then the arrow boolean. Here's a diagram of the lambda expression used above. The parameters are view key code and event. The function body consists of handle key events view key code, which uses the parameters passed in and returns a boolean. So there's view key code, event handle key event, view key code. If you don't use a lambda parameter in the function body, you can name it to make your code more readable and less cluttered. This code has the same behavior. So here this code has the same behavior. It's saying we're setting the on key listener with the key code and this underscore here to make your code more readable. They had the underscore instead of event, and then they have this. Okay. Make word list. Now let's take everything you learned about collections, lambdas, and higher order functions and apply it to a realistic use case. Suppose you wanted to create an Android app to play a word game or learn vocabulary words. The app might look something like this, with a button for each letter of the alphabet. Click the A Click the letter A would bring up a short list of some words that begin with A and so on. You'll need a collection of words, but what kind of collection? If the app is going to include some words that start with each letter of the alphabet, you'll need a way to find or organize all the words that start with a given letter to make it more challenging. You'll want to choose different words from your collection each time the user runs the app. First, start with a list of words. For a real app, you'd want a longer list of words and include words that start with all the letters of the alphabet, but a short list is enough to work for now. Replace the code in the Kotlin Playground with this code. So wants us to go ahead and place this code inside our Kotlin Playground. And so delete this. And then here's a list of words. And then to get a collection of the words that start with the letter B, you can use filter with a lambda expression and add these lines. So we can filter this list with a lambda expression, it's saying. So we can words that filter it that starts with B in lowercase equals true. then the filtered words. Okay, so this means it is retrieving all the words that start with the B. Cool. The starts with function returns true if a string starts with a specific string. You can also tell it to ignore case, so B will match B or B. Run your program and look at the result. Remember that you want the words randomized for your app. With Kotlin collections, you can use the shuffled function to make a copy of a collection with the items randomly shuffled. Change the filtered words to be shuffled too. So now, so and it says, remember that you want the words randomized for your app. With Kotlin collections, you can use the shuffled function to make a copy of a collection with the items randomly shuffled. Okay, so in addition, we want to shuffle our list so that it can be in a random order each time. So they added, let's see, they added a dot true, or wait, I'm sorry, a dot shuffled. Okay, so we did have that there. So when we play it, and then play it again, and then play it again, that it's not always in the same order. So best brief balloon, balloon brief best. Okay, great. Because the words are randomly shuffled, you may see the words in a different order. You don't want all the words, especially if your real word is long. Just a few. Just a few. You can use the take function to get the first items in the collection. Make the filtered words just include the first two shuffle words. Val filtered words equals words dot filter, and then take two. So it says you don't want all the words, especially if your real word list is long. Just a few. You can use the take function to get the first items in the collection. Okay. So they want to take just two from it. So, okay. So we can add this option to take two. And so basically we can add these methods with the dot notation. So it knows to shuffle, and instead of each being its own line. And then, okay, so we did two of those. So, so took two out of the three that are ordered by if it starts with a B, and then it shuffles it and takes two of those. Run your program, then we get that output. Again, because of the random shuffling, you might see different words each time you run it. Finally, for the app, you want the random list of words for each letter sorted as before. You can use the sorted function to return a copy of the collection with the items sorted. Alright, and then they want to, in addition to that, they want it to be sorted in ABC order, looks like. However, doesn't that nullify the shuffled if you want them, in the ABC order? Oh, oh, I get it. So it 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 takes the shuffled takes different ones from the original list. All right, I understand. So run the code. This is the output. All the code, and this is all the code above, which we have. Try try changing the code to create a list of one random word that starts with the letter C. What do you have to change in the code above? So they want one random letter, one random word that starts with the letter C. So this can be like filtered words too. And we can print out filtered words too. Okay, and then let's go ahead and play that. So we got a random word that starts with a C from our original list, which is coffee. And then we play it again. Then we play it again. Then play it again. Huh. Interesting. We play it again. Okay. So, yeah, it kept wanting us to give us coffee, but it did finally give us a different one, creative. In the actual app, you'll need to apply the filter for each letter of the alphabet, but now you know how to generate the word list for each letter. Collections are powerful and flexible. There's a lot that can be done, and there can be more than one way to do something. As you learn more about programming, you'll learn how to figure out which type of collection is right for the problem at hand and the best ways to process it. Lambdas and high order functions make working with collections easier and more concise. These ideas are very useful, so you'll see them used again and again. Summary: a collection is a group of related items. Collections can be mutable or immutable. Collections can be ordered or unordered. Collections can require unique items or allow duplicates. Kotlin supports different kinds of collections, including lists, sets, and maps. Kotlin provides many functions for processing and transforming collections, including for each, map, filter, sorted, and more. A lambda is a function without a name that can be passed as an expression immediately. An example would be a int a times 3. A higher order function means passing a function to another function or returning a function from another function. And so what we've learned is so, well, I encourage you guys to check this section out on your own time where it says to learn more. And so, vocabulary for Android, Basics in Kotlin, Kotlin collections, list class, set class, map class, collection transformations, high order functions, and lambdas, function types, implicit name for single parameter, lambda functions, and high order functions. And all right, so I hope you all learned something today, and that's actually going to be all for the stream for today. And I appreciate you all tuning in. And please go ahead and post any questions or comments that you may have to this video. And as always, I encourage you all to stay coding. All right. Bye. Have a great day.